So let's do a problem. This is for optimization, right? This is number 5 in the textbook, so 4.6, number 5. It says find the dimension of a rectangle with a perimeter of 100 meters. So I've got a rectangle and the perimeter equals 100 meters, whose area is maximized. Right, so I've already got the material for the outside, right? I've already got the edges of this thing. Maybe it's made out of wood or whatever. I'm trying to maximize the area here. So, and when I write down my step by step, I'll put all of this in. I want a picture. A picture is going to tell me a lot. And for both types of problems I give you, you can draw a picture, okay? So geometry problem, obviously geometry. Here I'm drawing a rectangle, right? For a distance problem, I'm going to be drawing a point in a curve, or two curves, right? So here's my rectangle, a little bit wonky. And I'm gonna be using two variables here. So I like to use x and y. You can use anything you want. So I'll call that piece x, this piece y, and I know my perimeter, right, is 2x plus 2y equals 100 meters. I don't care about units. Let your science teacher teach you all about units. I do want you to put units in at the end when you put your conclusion, but we don't need them when we're calculating. Right?
This is something where whenever I had geometry class, I would just middle finger to the person who invented units, and I put U for my units.
So what I'm going to come up with once I draw a picture is I need some kind of equation, right? And I clearly have that, an equation in two variables. But I'm also going to have some expression that I want to maximize, but in two variables, and that's the problem. I want a max area, right, of what? X, Y. I don't want to start talking about two variable functions. F of x, y is x, y. I don't want to do that yet. So that's for Calc 3, for those of you that are going to take it. So we want to get a max area of a two variable expression, okay? Every time we're going to do something like this. So now what I need to do is solve for y in the first equation and sub into the second equation, right? So what do I get here? I get y equals 100 minus 2x over 2, so 50 minus x. So that's my y value. I'm going to take that and plug it into my expression. And now I want a max area, max the area of f of x equals x times 50 minus x. Ha ha! And you can see now this is a quadratic that opens down, so it's going to have a max, right? So what do I do? Critical value, right? So I get f prime of x is going to give me 50 minus 2x. So x equals 25. Well, it's kind of boring. If x is 25, the other x is 25. How much is left is 50, so y is 25 also, right? So I can already see it's a square. So my max area turns out to be a square in this case. So I got this x is 25, I got this x is 25. I got this side was 25, I got this side is 25. So x is 25 meters, y is 25 meters, right? The perimeter is 100 meters, and the area is what, 625 meters squared? Is that right? Yeah. And I want some nice written conclusion, right? If I have a perimeter of 100 meters, I get a max area of 625 meters when x equals y is 25 meters. Some kind of final answer that includes all the details. Find the sides, find the area, find the perimeter. I'll assume question.
Yeah, it's just like a geometry thing. Was there like a rule that not are all rectangles or all squares can be rectangles, but not all rectangles can be square? Something?
All squares are rectangles.
Okay.
Yeah. So the only thing I need for a rectangle is the right angles and opposite sides are parallel. And it doesn't matter if all four sides are the same or, opposite pairs are the same. So squares are rectangles. Cool. If there's any weird geometry, I'll give it to you. Okay? If there's any weird geometry, I'll give it to you. So let's do another problem. Oh, let's do a step by step. Do you like the step by steps?
Yeah, for the conclusion.
Yep. Nice. Let's do a step by step. Read the problem. Duh. Right? We're going to try and draw a picture. Right? Create an equation in two variables. Right? Find or discover an equation in two variables. Write an expression in two variables to be maximized or minimized, right? Solve for one variable in the equation and sub into the expression to create a function of x. Solve for y in the equation and sub into the expression to create a function of x. Then we're almost doing a first derivative test, but we're going to use the second derivative to tell us that we actually have a max or a min. Okay? I didn't do that on the last one. I should have. But I'll do it on the next one. So 6, find f prime of x and the criticals. I'll just say C, right? It might be a couple of them, but usually it's one. In most of these problems, it's one critical value. show f double prime of c is a max or a min. Remember, if f double prime is negative people frown, I'm going to be at the top of the hill. It'll be a max. If f double prime is a positive people will smile, I'll have a minima, right? A min. Find the values mentioned in the problem. So I had to find a side x, a side y, an area xy in the previous problem, and then write a conclusive conclusion. So we found the maximum of this with the side of this and an area of that, and we knew it was a max because of the second derivative test, yada, 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 right? Oh my God, imagine if I did this lesson on Friday. I was so burned.
Chaos.
I'm still exhausted. I went all the way to New Jersey to help family again this weekend.
That sounds like fun.
It's horrible. Don't get old. That's all I'll say to you. Don't get old. All right, let's do another problem.
That beautiful I-95 traffic.
Yes.
Who could complain?
Right.
Professor, can you zoom out so I can take a screenshot?
Yes, sir.
Okay.
All right, this is number 25. What I've decided we're going to do is we're going to do our 4-6. I should finish 4-6 on Wednesday, and then I'm going to skip 4-1. I'm just going to skip related rates. We're not going to put it on the test. And that way we stay on schedule. So the homework that I put on homework 7 and 4-1, just don't do it. So just start working on 4-6. It'll still be due Monday. Okay. So this is number 25, 4.6, number 25. Related rates is something that we don't need for Calc 2. We do need this optimization piece for Calc 2, so I'm okay with skipping the piece that we don't need for Calc 2. I've got a piece of wire, a length of wire, you know, something that's kind of rigid. I can bend it though. Is 10 meters long. But cut into 2 pieces. One piece is bent into a square, bent into the shape of a square. The other bent into the shape of an equilateral triangle. So you're going to see 2 pictures. Here's my wire cut into 2 pieces, right? Here's my square. And here's my equilateral triangle, right? So I want to maximize the area, the sum of the areas.
So we can't assume that you just wrote it that way, the line, right?
Yeah, it's
We
a
don't
piece
know
of
which one's
y.
larger.
That's right. We don't know which one is longer than the other, but we're going to call one of them X and one of them Y. Exactly true.
Okay.
Exactly true. So, using our checklist, and this is one that I would give you the area of an equilateral triangle, right? So I would give you the area of equilateral triangle with a side of S. Is
I remember it being a 1/2 something.
yeah, it's 1/2 S
is of a height.
rad 3 S over 2.
Wow, I remembered something.
Yep. So that would be rad 3 over 4 S squared. I want to double check that, but I'm pretty sure that's it. But I'm saying, if I give you something this complicated, I'll give you the formula, okay? Like if I gave you the volume of a right cone, I'm talking about an ice cream cone, right? I would give you the formula for that. If it's a box, I don't think I need to give you those. But, I mean, you certainly could ask me, right? If you're really that unsure about it. And if you had the perimeter of a square wrong, I guess I could take a little bit of mercy on you and just grade it from there, right? Take 1 point off and then grade it with your incorrect basic formula, right? All right, what's my equation? The length of wire is 10 meters long.
Four x plus 3y equals 10?
No, you're doing perimeter, right? So we've got to do an area but don't mix the two. Could you just have an equation for me here? I like the thought, though, Jess.
Okay, so area of square plus area of...
Okay, good. That's what we have to
triangle.
maximize. That's right. That's what we have to maximize, right? So this is going to be x over 4, right? And the equilateral triangle will be a y over 3, right? 4 sides for the square, so I got to bend a quarter of the wire for the square and a third of the wire for the triangle, right? And then I have to figure out the area of each. But what's my equation? What's my equation? X plus y is what? How long is my wire?
Equals 10.
Yes, so y is 10 minus x. So that's going to be my substitution piece. I know the area of the square is side times side, is side squared, right? So that's x squared over 16. The area of the triangle is going to be rad 3 over 4 times y over 3 cubed. So that is rad 3 over, don't tell me, times y cubed. I just had to double check my area one more time, sorry, of the triangle. If this is s over 2, this is s, and this is square root of 3 times s over 2. And half the base is s, and then square root of 3 times s over 2. Yes, I have it right. Okay. Just double checking my formula that I would give to you. Yes, you with me? When it's really complicated, I'm gonna give you the formula. All right. So I've got my equation. I know what I'm trying to maximize, but I want to maximize a function of x. So I want f of x to be x squared over 16 plus rad 3 over 108 times 10 minus x cubed, right? I'm taking that y value and plugging it in there, right? Yes, we're okay? All right, f prime of x. Well, the 16 goes for the ride, so I get times 2x. The rad 3 over 108 goes for the ride, so I get times 3 times 10 minus x quantity squared times another negative 1. Right? I'm just doing chain rule there. Double check me, please. Do it yourself, and let's see if we get the same thing. Yes, we okay? We get the same? Nice. So I want to, this is kind of nasty, right? So I guess I can get an LCD. Do I need to? I guess so. LCD, I'm going to just do birthday cake method here. I get a 4 and a 9, and I think that's it. So 16 times 9 is my LCD. 144. So I'm going to make this 144, right? And I want to make this 144. So I just need to figure out, right, 144 divided by 8. This is, I need an 18x here, and 144 divided by 36, 4. So I'm just getting an LCD, right? I don't care about that anymore. It's a constant. So it looks like I just have to, just got to set this numerator equal to 0, right? Now, I don't think there's a way around it. I gotta FOIL it out and distribute and see what happens. Yep.
there's anything you've shown me, is there's usually 100 ways to solve a problem without doing it the Dumbo brain way, but sometimes you just have to.
Yeah, unfortunately. I don't know why this didn't turn out nicer. I don't know if I made a mistake somewhere else. I really just don't feel like doing this. I'm going to cheat. How am I going to cheat? I'm just going to look at the answer. I don't remember it being so hideous when I did it with the other class. 4.6, number 25. I won't put something this hideous on your test. Well, that might not be true either, but...
What? No 3D objects?
I get a critical value of x equals 40 rad 3 over 9 plus 4 rad 3. That's what I did get in my other class, but I don't remember why it seemed so difficult to me today. I just guess I'm brain dead. So there's my critical value. Obviously, I solved some quadratic. I can't do any more today. I'm sorry. I just can't. I can't keep going. I don't have time to finish it, so I don't want to bother. I'll do a nice easy geometry problem and my distance problem that I put on every test next class. The problems that are in 4.6 that I assigned, the geometry ones you can start doing right away. Okay? So let me just go back. Let me do this. I want to go back to that one problem I started.
Oh.
And
was there on Friday you meant? Oh, this is part of homework 7. Okay.
Yeah. So f double prime of x. So if we look at my derivative of that first problem I did, right? 50 minus 2x. If I take the second derivative, I get negative 2. If you remember, I got a critical value of 25. So f double prime of 25 is still negative 2. It's negative. Negative people frown, so I must be at the top of the hill. I had to get a maximum out of that, right? So that's the one piece I didn't put in from my step-by-step, right? That I want to make sure that you find f double prime of the critical value is max or a min, right? Well, the wire problem, yuck. The first problem, easy. There's a bunch of I think the problems I assigned. Who can tell me the problems I assigned in 4.6? Sorry, Lucy. Sorry, birthday girl.
You just did 25?
No, the ones I assigned on Blackboard.
Sorry.
$11, $15, and $25.
Nice. Oh, so 25 you're going to have to finish yourself. 11. Easy. It's a box. 11, 15 is a distance problem. Wait for me on 15. and 25. I know that I made something more complicated than I need to find a critical value. But you know what the critical value is now. So you should be able to get there. Okay. All right. Nice. See you all Wednesday. Udi, if you stick around, I did your problem if you want to take a look at the... I'm sorry, not Udi, Markins.
Yes, please.
If you stick around, I did that problem first.
Yeah, I obviously this morning.
It happens. It happens. No big deal.
I don't like it, Professor. Don't like it.
Okay, see you Wednesday. So, Udi, we got... There's our graph. Okay.
Yes.
And then we finally got a derivative of this. There's our derivative.
Yes. Okay.
So if you want to take a photo of that.
Yeah, let me do it.
Yeah.
For all of them, please. Okay, you can scroll up.
Okay, now we got a critical value of e squared. There's my critical value of e squared. And then I checked my test values were 1 and e cubed, just because I know if I plug those in to the numerator, I can get an easy answer.
Okay.
And then there's my first derivative test, but then I didn't write a conclusion because I know the issue was either your derivative or it was finding the critical.
Yeah, but my problem is for the critical value. I'm having trouble with it. But I can start. The problem right now, I can start the problem, but I can't finish it.
Good, exactly.
This is my problem. Like I start some of the homework, but I can't finish it. I don't know what you just check. Tell me what you think about it, please.
Well, I mean, first of all, did you get the right derivative?
Yes, I did. But
Okay. So then set the numerator equal to 0. And you can see the bottom blue box there. It says 2 minus ln of x equals 0, right?
Yes.
So ln of x equals 2. So raise both sides to base e.
Yes.
And you get x equals 2. E squared.
Okay.
Yeah.
Okay, I got it. Can you go and then like the second one you did in class also?
Which one?
Oh, I don't see like the everything like you done like side one page 2.
Oh, you mean the other one that you missed this morning?
Yes.
4.3 number 1. You taking photos?
Yes.
Done?
Yes.
4.3 number 29. This is a second derivative test.
Okay. I got it.
Okay, nice. Yeah, that's it.
Okay.
Nice. I've got office hours now, but does anybody have questions for me?
Yeah, but
No, I was just sticking around until Markins and Pedro were go have your breakfast.
Yeah, but I have office hours, so I gotta keep my room open. So you guys are gonna have to meet somewhere else.
No, yeah, we
yeah,
are.
Bye, Jesse, bye, Pedro, bye, Professor.
All right, see you later.
Yeah.
Yeah. See you Wednesday.